Hello and welcome everyone to Summary Shorts, and in this short video I'll try and prove that ZX is not a PID. What I will do, I'll prove that the ideal generated by 2nx is, which is an ideal of ZX, this is not a principal ideal. Okay, and our method of proof will be sufficiently by contradiction. So let the ideal generated by 2nx be generated by some element fx, that which is a polynomial over z. But what does that immediately imply? That immediately implies that the element 2 must be in this ideal, which implies that 2 must be equals to this polynomial times some other polynomial over z, right? But we know that z is an integral domain, that is, it has no zero divisor, so zx is also an integral domain, and therefore if I apply the degree on both sides, where delta means degree, so the degrees must add up. This is an important property of polynomials over integral domains, and we know that polynomials are strictly non-negative, and on the left hand side we have something 0, so that means that the fx is a constant polynomial, its degree is 0. So what do we conclude? That immediately concludes the fact that fx must be actually an integer, right? So I can replace it by symbolically as some element f. Okay, but and also we can also see from here that the degree of g must also be 0, so that is also an integer. In other words, what do we conclude is that f is an integer which divides 2. Now 2 is a prime, so f must be either plus or minus 1 or plus or minus 2. But now clearly f cannot be equals to plus or minus 1, because we know that if I consider an element, so rather if I consider an ideal generated by plus or minus 1 in Z, then this ideal should actually be the whole ring Z. But that is not actually possible, because this ideal 2x, this is not the whole ring of polynomial Z. Actually I want to talk about this, because I am talking about this in ZX. And why is it so? Because the polynomial, let's say 1 plus x, this is not in the ideal generated by 2x, because it is having an odd constant term. Nevertheless, what do we conclude is that, so my f can either be plus 2 or minus 2, but then clearly observe that the ideal generated by 2 should be of the form 2 times f of x. Each element should be of the form 2 times f of x, where f of x is an element from Zx. What does this immediately means? This immediately means that x cannot be in the ideal generated by plus or minus 2, because the coefficient of x is odd, while the coefficient of any element in this ideal should be a coefficient of any coefficient of the x element must be odd, right? But must be even, but here it is odd, right? Therefore this is a contradiction.